If you run a YouTube channel or a vlog or anything like that, and you want to upgrade the quality of your production, you may have bought what I did, the Canon Video Creator Kit, which is a Canon M50 camera, and it comes with some really nifty accessories, including the Rode VideoMic GO. And this is a nice little mic, and it's great that it comes with the kit, and I think you get a good deal, but you probably also discovered, like I did, that this mic has a serious drawback, and that's that it picks up a lot of electromagnetic and radio frequency interference. So stick with me through the rest of this video, and I'm going to show you how to fix at least most of the noise problems with the VideoMic GO. Audio is incredibly important to the quality of your video production. A good video is great, but if it's got lousy sound, people are going to hate it and they're not going to watch it. So you need good sound quality, and that means that you need some good microphones. And it is great that the Canon Creator Kit comes with a nice shotgun mic, because this will give you greatly improved audio over the built-in microphone in your camera. However, the VideoMic GO is one of the lower cost options from Rode. And in order to save cost on this, one thing they did is they built it with a plastic mic body. And the thing with plastic is that it doesn't block electromagnetic or radio frequency interference. Metal is great for that, plastic sucks. You can put carbon in it, you can make it ESD safe, but you really can't make it into a good Faraday cage. So as a result, the plastic body on this mic doesn't shield anything. And if you get close to something that emits a lot of RF interference, like a Wi-Fi router or electrical appliances, things like that, you'll definitely pick up a lot of clicking noise. So how do you stop that? Well, we need to shield this microphone. And I'm not the first person to suggest this by any means. There's a lot of people who've posted videos on how you can wrap this with foil, wrap the cord with foil, and those things help. And they're great. But the problem with that is that foil is going to make noise, and it's hard to make it stay on the microphone, so you have to wrap it with foil and then maybe tape it on there. I thought about doing that, but I didn't really like that approach. So what I did is I used some copper tape to shield the microphone. And this copper tape is available from electronic suppliers like DigiKey, and you can also get it directly from Burtech. And a roll like this that's 3/8 or 1/2 inch wide costs about 15 or 20 bucks, not including shipping. So my microphone is already wrapped. You can see that I've got copper around the back half of the microphone there. And in fact, if we pull the windshield off, you can see that I've wrapped quite a ways up around the actual condenser element in the microphone. And I'm going to show you how I did that. Mine's obviously done already, but I'm going to show you using a proxy how to wrap this thing and get good shielding. The cord that comes with the VideoMic GO is coiled, and that's really a nice feature because it keeps the cord from getting tangled in things when it's on the camera. And it looks really short when you look at it, but if you do the math, this is literally a 2-foot cable. There are 20.5 turns here, each one's about 5/16 of an inch, plus 2 inches on each end. Comes out to 24 inches. So this cable is fairly long, even though it doesn't look like it. And that coiled shape actually might contribute to it being an antenna. I was concerned that this might be a factor for noise pickup. I experimented with a different 3.5mm stereo cable. Unfortunately, the shortest cable I have is 2 feet long, so it's the same length overall, and using this actually made the noise worse. So this is not something I would recommend. So you're probably better off sticking with the Rode cable that comes with the mic. However, I did find a 1-foot cable with right angle ends on DigiKey that might be promising, so I'll put a link for that in the description. So here is the Rode VideoMic GO, and you can see it comes with this really nice lyre suspension mount and cold shoe attachment point. But the first thing we want to do if we're going to shield this microphone is remove that mount, and it's held on by 2 little spring-loaded tabs. So to get the mount off the microphone, I'm going to use a small screwdriver to press the little tab on one side and the other, and just kind of walk it off the mount. There we go. Once it starts to go, it's pretty easy. So you can see that I've got it loosened, and then basically it just slides off. So there is the mount and the microphone separated. Now to wrap the microphone, first thing to do is remove the wind noise filter. It just slides off the end, and that exposes the microphone plastic body. So you can see my microphone is already wrapped, and I'm going to show you using another cylindrical object just how I layered the tape and got a nice solid contiguous shield around all of the microphone elements in this microphone. So our copper tape obviously is flat, but we have to wrap it onto kind of a complicated curved surface. So how do we do that? Standing in for my microphone, I've got this cardboard tube and some blue painter's tape. And I'm just going to show you how to wrap this to get a good continuous shield. So the key to having a good shield or a good Faraday cage is to not have any more gaps or openings than are absolutely necessary. So what I did is I took the copper tape and I made pieces of it, and then basically starting with some overlap around the ends of the microphone body, I wrap the tape on there, and then end that tape in the right place. And then to close it off or to go around the more complicated curves, you basically are going to tuck it in and fold it over like this. And just kind of close off the areas like around here. You can see you have to double it over and plan ahead so that the tape ends up kind of close to the inside body of the microphone there. And then on these inside surfaces, I also laid in strips of tape and pressed them in carefully into the corner, right? And what you want to do as you're wrapping this tape, anytime you put down a new piece that overlaps, you want to burnish it. So I used my fingernail, but you could use a plastic spoon or a nylon spudger or any kind of tool that would give you a good ability to burnish that tape down. You want to really kind of get it well burnished so that it's sealed against itself. And where you have tight spaces, use smaller pieces of tape. Larger spaces, you can use longer pieces. And basically just wrap this until it is fully shielded. Now, one thing I want to point out that's important is that at the back of the microphone, you want to actually close this off. Put a piece of tape across the microphone jack, and then I used an X-Acto. I didn't do a great job, but you can see I basically cut a hole in here for the plug. And if you look at the end of the plug here, you can see that the shield, which is this last portion of the barrel of the connector, the shield actually extends up into a flat T surface there. And that, if you do this right, when you plug this in, it'll rest against the copper tape and make a connection. And then what that means is that the shield in the microphone is contiguous with the shield in the cord. I can demonstrate that with the multimeter. I'll set my multimeter to continuity, right? So when the two probes are touching, we know there's electrical connection because it beeps. And I'm going to touch the shield on the microphone, and I'm also going to touch the shield on the other end of the cable. And you can see that I've got a continuous electrical connection all the way from my copper tape, even way up here by the actual condenser element, to the shield on the cable. And it's a little hard to get a connection sometimes through the oxidation on the copper. But there, you can see that is electrically continuous. And what that means is that any noise that's picked up by this gets shunted into the shield and eventually returns to the ground in the camera. And that means it doesn't get into your signal, hopefully. So you want to wrap all the portions of the microphone that have electronics inside them, and you can actually see one of the condenser elements. And then in the base of the microphone, obviously, is where the amplifier is. This microphone is powered. It receives 2.5 volt power through the cable, so it does need plug-in power, and that means there's a little amplifier in here. So we want to shield all the base of the microphone, and we also want to wrap a little ways up around the tube here. You don't have to wrap this whole thing because there's really nothing in there. In fact, you don't want to cover this side here because it's hard to see on camera, but this is actually a mesh. There's actually a nylon mesh there, and there are vent holes through the side of the mic. And I think the idea here is that sound enters the front and sounds from the sides are blocked or filtered so that you end up with a directional pattern for this microphone. When you're done wrapping the microphone, obviously reinstall the wind filter, and then the mount just slides back onto this plastic tongue here and snaps in place. And then you're good to go. At the beginning of this video, I played a clip of the clicking and popping sounds that you get with an unshielded Rode VideoMic GO. And in order to compare and show how this copper tape shielding has improved things, I put the camera and mic back in the same location and shot another short clip with the same equipment running to show you that the noise is basically gone. Alright, I'm doing a really quick and dirty test here. Just checking to see if there's any noise with my camera sitting right between my two computers with both Wi-Fi interfaces running. Hopefully we don't get any clicking. That said, even with this copper tape shielding the back half of the microphone, in a really noisy EMI RFI environment, this mic will still pick up some clicking and popping, especially with automatic gain control. So to show you that, I took my camera and mic into the closet and went right next to the Wi-Fi router and the cable modem, and you can still hear some of the clicking and popping. Now the mic does still pick up some noise in those environments, but I think that there may still be some gains to be had by going to a shorter cable. So I'm going to try that and see what happens. If you got this mic for free like I did in the Video Creator Kit, it really seems a shame to put this aside and go out and spend more money on a fancier mic like the VideoMic Pro or the VideoMic Micro from Rode, which do eliminate the noise, but then you're spending additional money on top of what you spent for the kit already. So I'm hoping that by applying this copper tape shielding, as I've shown you in this video, you might get the same improvements I got, and it might eliminate most of the noise, especially if you're not immediately adjacent to a Wi-Fi router or other signal generating equipment. So if this was helpful to you, please click the like button, and if you enjoy the sort of content I'm producing, please subscribe to my channel, and I will catch you next time.